Up to now, we've been dealing with point charges. Now I want to look at the concept of charge density. We're going to have three different types of charge densities: line charge densities, surface charge densities, and volume charge densities. A line charge density might be a useful form if you had a rod that had charge distributed on it. The symbol we use to indicate line charge density is rho with the subscript of L. As an example, let's say we had a rod that was of length 2 meters, and that for every meter of length there were 3 coulombs. So we would say the line charge density is 3 coulombs per meter. So the total charge on our line will be the 3 coulombs per meter times our length of 2 meters. The meters would cancel, leaving you with a total of 6 coulombs on our line. If you're dealing with the capacitor, surface charge density might be a useful concept to describe the density of charge on a capacitor plate. A surface charge density is the amount of charge per unit area, or coulombs per meter squared. The symbol rho with the subscript S is used to indicate surface charge density. As an example, we have a plate that's 3 meters by 2 meters, and the charge density on the plate is 3 coulombs per meter squared. So for every square meter of plate, you would have 3 coulombs. The total charge on this plate will be the charge density of 3 coulombs per meter squared times the plate area of 6 meters squared. The meters squared cancel, and you're left with 18 coulombs on this plate. Our final charge density is volume charge density, and it is indicated with the symbol rho with the subscript V. Volume charge density is the amount of charge per cubic meter. As an example, let's say we have 5 coulombs per cubic meter. That means for every cubic meter you're going to have 5 coulombs of charge. Let's assume we have some volume here that has a total volume of 10 cubic meters. So the total charge on this object is the charge density of 5 coulombs per meter cubed times the volume of 10 cubic meters. The meter cubes cancel, and you're left with 50 coulombs as the charge on that object. In these examples, we were assuming uniform charge densities, but the charge density can vary with position. In that case, to find the total charge on an object, you would have to do an integration. Let's illustrate that concept by working an example problem. We're given a region that has a surface charge density, and the surface charge density is a function of both rho and phi. And you're asked to find the total charge on this region. The starting point for most problems in this course is drawing a figure. Phi is an angle that an infinite half-plane attached to the z-axis makes with the x-axis. So when phi is 0, you're along the positive x-axis, and when phi is pi over 2, you're along the positive y-axis. So this region is going to be contained in the first quadrant. Rho is the radius of our cylinder, and it's going to go from 0 to 2 meters, and as we just saw, the region will be confined to the first quadrant. So we've defined the region on which we have charge. And our surface charge is going to vary with our rho component, and it's going to vary with our phi component. Here I'm illustrating some of our differential surfaces. Let's focus on this one. So this side is of length d rho, and this side of length rho d phi. So this differential surface is equal to rho d phi. So there's a charge associated with this differential surface. It's just the surface charge density times the area ds. So the charge associated with this differential surface is rho sub s rho d rho d phi. To obtain the total charge in this region, we would have to sum up the dq's from rho equals 0 to 2 meters and phi equals 0 to pi over 2 radians. For dq, let's substitute this expression. For rho sub s, we will substitute this expression. Rho sub s has units of coulombs per meter squared. ds has units of meters squared because rho is in meters and d rho is in meters. So this will indeed give us charge. I've rearranged this equation and indicate its units of coulombs. Performing this integration, we'll get a rho cubed over 3 evaluated between 0 and 2, which will give us an 8 over 3, and integrating phi d phi will give us a phi squared over 2 evaluated at 0 and pi over 2, to give us a total charge in that region of 8, 6, pi squared over 4 coulombs, which is pi squared over 3 coulombs.